Hello, welcome to Farnborough Aviation Show. This is an exciting second day. It's coming to the end, but there are a lot of interesting and productive discussions with a lot of operators, manufacturers, representatives of the government. And we already had a few live streams here from the session, from our stand. And now I will talk about the hydrogen infrastructure. So hydrogen is actually not a very scarce commodity, and it is, if you think about this, it's about 70 to 80 million tons of hydrogen produced annually in the world. And unfortunately, only 1% out of it is made out of what called green hydrogen. And green hydrogen is produced from the electrolysis of water. And the rest of hydrogen, about 50% of it is produced from natural gas. We call it gray hydrogen. And about a quarter of it is produced from coal. It's brown hydrogen, and the rest of it is either from oil or as a byproduct of oil. So if you calculate, if you give a price to 1 kilogram of hydrogen as $1, it will be $100 billion industry. So we don't see it because majority of hydrogen is used in fertilizer industry and in chemical industry, and it's not used as much in the transportation sector. Now, if you look at the different forecasts, how hydrogen is going to be used going forward, you can see on this graph that there are a lot of different uses forecasted, and from today's about 80 million tons, we'll get to something like 5 times bigger than that. And different forecasts again give different numbers. But, we believe that transportation will use about the same number, the same amount of hydrogen is used today for transportation alone. And for the aircraft, of course, it will require again green hydrogen in order to decarbonize the different sectors, including transportation. We need to have green hydrogen. Green hydrogen requires to have green electricity because again, if we use electrolysis needs to have clean electricity. Clean electricity means low or zero carbon electricity, which comes from either renewable power generation, which is solar, wind, or hydro, or nuclear power generation. So in order to produce all that, we need to have, of course, a lot of renewable power generation. And if you just multiply, how much electricity is used to produce all this hydrogen, you will get very easily to the numbers that you need to have about the area of Belgium to produce all the hydrogen, all the green hydrogen, which is needed by aviation. If you think about this, this is a huge number. It is, from one hand, it's huge, but it will take us about this area we need to cover by 2050. So we have another 30 years to. So this is not definitely unsurmountable, and of course on top of that we have other power sources like nuclear reactors or small nuclear reactors, etc., so which can be built at scale and produce low carbon or zero carbon hydrogen. So there are about 1,500 of total hydrogen projects were announced a few years back, and we anticipate that about 1,000 of them will be completed by 2030. So this is these projects will contribute to production of about about 40,000 tons of hydrogen. This is about half of what we need to achieve by 2050. Okay, so of course, all the projects will materialize. You know, it will be we will not be in the hydrogen deficit. Okay, so why is it important? It is important because similar to what we saw in industries like solar or wind electricity, that we started with pretty expensive, solar and wind power generation, and as the scale kicks in, you will get cheaper and cheaper. You got the cheaper and cheaper solar panels. You got cheaper and cheaper wind turbines. And we expect that we will have a very similar trajectory in hydrogen production. So using different forecasts, you can see that LCOE or levelized cost of LCOH, sorry, levelized cost of hydrogen can be is predicted to be quite different. And we anticipate that in any scenario, we have 3 different scenarios here. In any of these scenarios, we will get to the cost of hydrogen cheap enough so that we will compete with the jet fuel. And there are different figures of merit which are named. So, for example, we are operating with a number something like $5 or $6 per kilogram of hydrogen, so that we can compete with the jet fuel. Now, for example, DOE in the States is setting up the targets to achieve the cost of hydrogen production of about $1 per kilogram by 2030. Of course, it's an ambitious target, but I think that it's I believe that it is truly achievable, because again, coming back to the experience of solar and wind industry. Today's electrolyzers very often are produced, those stacks are produced by hand or in very low automation environment. So now if we go into the really automated, high-scale, gigafactory type of environments, we can achieve the numbers which are anticipated not on the high projection curve, but on the optimistic curve. So you probably already heard that ZeroAvia has quite a lot of orders on our book. So we have orders for about 2,000 engines among different operators and players in the industry. So when we talk to our customers, of course they ask questions. So where do you get the hydrogen from, and how are you going to deal with it? And of course, what we are saying is that we are going to implement whatever we already have done for our demonstration flights, and we have flown ever since on hydrogen ever since September 2020. So soon it will be 4 years we've been flying on hydrogen, and for that we produced our own hydrogen. And on this little cartoon we have, of course, the renewable power generation, then electrolysis to produce hydrogen. Then we have compression unit and the storage unit to store hydrogen. And the last but not the least is the mobile refueler, which works in a similar fashion as today's refuelers on the airport premises. Basically, they take jet fuel, from the storage, and they bring it to the aircraft. The same on our premises. The situation will be, somewhat similar when we go from gaseous hydrogen to liquid hydrogen, and the only major difference is that very often hydrogen will be either, produced again on premises, or it will be brought in pipes, piped into the airport premises. And what will happen then, you need to liquefy hydrogen. So the liquefaction units will be on the airport premises in this case, and then we will have storage facilities. And again, liquid hydrogen mobile refuelers. And ZeroAvia is working on all the components of this, except for production of hydrogen. So we have in particular, the very important piece is the mobile refuelers, both liquid hydrogen and gaseous hydrogen. And this is we have different projects, both in operation, but also in development. So very often, if you go to the different conferences or participate in panels, we asked what type of challenges we are facing. And of course, in order for the industry to fly without any support, I think that we are getting close to that. We need to have hydrogen available and hydrogen at low price. And of course, this is a part of what our infrastructure team is doing, is having a very important relationship with electrolysis manufacturers and different components manufacturers, but also with companies which produce hydrogen at scale. And recently we had an announcement that we signed the agreement with RISE to serve as an alternative supplier to our hydrogen here in the UK. Then, of course, we need to have a unified vision of the industry on how hydrogen is going to develop. I think that it's from one hand, it's how are you going to refuel, what kind of standards you're going to be using, and what kind of speeds, at what kind of speeds you would expect those refueling effects to take place. And of course, that feeds into the safety and the certification and standardization frameworks. And as I already mentioned, ZeroAvia is working on all different pieces of that. So, for example, we are developing, as I said, different pieces of hydrogen infrastructure, in particular mobile refuelers for both gas and liquid hydrogen. So we are working very closely with all different components and equipment manufacturers in the hydrogen ecosystem. And the last but not the least is that we are participating in the building up of the ecosystem, which will work safely and synchronized like what today's airport ecosystem works. We are doing that by signing a lot of agreements and doing actually practical work with different airports. So recently we announced about the agreement which we signed with together with Airbus with 3 major airports in Canada, for example. It's Vancouver, Toronto, and Montreal. We have I think about something like 40 different airports. We have partnerships with on different topics. And also what we are working on is setting up the framework for different standards and regulatory frameworks for dealing with hydrogen on the airports. Because again, when you mention the word hydrogen, people get scared. And people get scared just because they don't know. They don't know, for example, the fact where I started with that. It's if you look at hydrogen industry, by itself, it will be $100 billion industry, and nobody, a lot of people don't really know about that. So, what it means is that people, we know how to work with hydrogen safely. We know how to regulate, we know how to transport, how to move it one vessel to another. It's just bringing this knowledge about the safety and security into the airport environment. And this is what our team is aggressively working on to actually make sure that it's real, it's live, and it's working not only in our facilities, which are in Kosovo Airport, in Everett, in Hollister in the States. And last but not the least, I think that I wanted to conclude on the note that this is often people tell us, you're working on the future of aviation. And my argument is that it's not the future, it's today, okay? Because we are already going to fly commercially in a couple of years. So by aviation standards, this is not the future. This is actually today. And I think that this is exciting time to be in our industry. This is the time when we can tackle some of the challenging problems like what we are working here on decarbonizing and increasing the sustainability angle of aviation. And our team, which is presented here, everybody is excited to be part of this journey and contribute to the better world of a better life tomorrow. Thank you. Any questions?
So the liquid hydrogen tanks are pretty heavy. How much energy does it take to at sub minus temperatures, and how much space does it take on the plane?
So the question is just for the live streaming. The liquid hydrogen tanks are heavy, and how much energy do we need to produce to keep them, at liquid gas hydrogen liquid state? So I think it's a good question. So if you think about this, gases tanks are more. If you look at the gravimetric density, so the typical gravimetric density for the gaseous hydrogen tanks, which you use in Toyota Mirai, for example, operations, it's about let's say 5 to 6%. So if you go to the best in class compressed hydrogen tanks, they can produce about give or take 10 to 11% gravimetric density. So what it means is that for 1 kilogram of hydrogen, you will need to have at least 10 kilos of storage vessel. So now, if you go to liquid hydrogen you can keep you keep it at pretty low pressure. So you don't need to have massive infrastructure which you need for gaseous hydrogen. And the gravimetric density of hydrogen actually increases from about, as I said, 5, 6, or 10, 11% to 30%. Or even there are some demonstrations that it can be up to 60%. 30% means that for 1 kilo of hydrogen, you need to have about 2 kilos of storage tank. So on the scale of things, not very heavy, infrastructure in case of liquid hydrogen. Of course, it is about 3 times. It takes about three more times space than jet fuel, of course. But that just means that we cannot stick at the wings. We need to put it inside of the somewhere on the tail of the aircraft in the fuselage, or somewhere externally. But it's not huge amount of volume. Now, in terms of how much energy we need to use in order to keep it cold. So, for example, one of the projects we are doing is the zero boil refueler, which uses just a little bit of electricity and compression to keep it the boil off close to zero. Now on the aircraft, if you we are going to use liquid hydrogen, but we are going to use fuel cells. And if you think about this configuration, we need to gasify liquid hydrogen anyway. So even if it evaporates, it will serve as a fuel inside of the hydrogen fuel cell. So we don't need to apply extra compression or make any extra efforts to keep it liquid. Okay, thank you very much. And I think we conclude this live stream, and I think that we will have a few more live streams from Farnborough Aviation Show. So stay tuned. Thank you. Bye bye.